Okay, we are going over notes on solving absolute value equations. And so before we dive into these notes, I want to bring back up this graph of our absolute value parent function. So some things that we notice about this function is that all of our y values are positive. And that's because our absolute value refers to the distance that a number is away from 0. And this value is always going to be positive because we're talking about the distance, how far away a number is from 0. So both 2 and -2 are 2 away from 0 on the number line. So that's just what we need to keep in mind today as we delve into the world of absolute value equations. So starting with our notes, if we're talking about the absolute value of x is equal to 3, that means I'm looking for numbers that are 3 away from 0 on our number line. So if this is my number line and this is 0, there are 2 numbers that are 3 away from 0. And that would be 3, 1, 2, 3, and -3, 1, 2, 3. Both of these numbers are a distance of 3 away from 0 on our number line. So keeping that in mind, if we were then told that the absolute value of 4x plus 5 equals 10, that means I'm looking for numbers that when I plug them in for x, give me a value that's 10 away from 0 on a number line. Now recall, there are 2 numbers that are 10 away from 0 on a number line, and that would be positive 10 and negative 10. So I'm looking for values of x that either give me positive 10 or negative 10. So we set what's inside our absolute value, in this case 4x plus 5, and we're going to find what would give me positive 10 and negative 10, because both 10 and negative 10 are a distance of 10 away from 0. So this is just then, a two-step equation. We get 4x equals 5, divide by 4, so x is 5 over 4, or, again, two-step equation, subtract and divide, we get negative 15 over 4. So those are the 2 possible values for x to satisfy this equation. So let's practice that again. The absolute value of 2x minus 16 is 10. So again, we're looking for values of x that when plugged in here give me a number that's 10 away from 0 on the number line. So that's going to be 10 or negative 10. So again, two-step equation. So x could be 13 or x could be 3. Okay. Practicing again, example 2, we have one new feature here, and that is this plus 8 being outside of the absolute value. So before I can set this equal to my positive and negative, I need to move that 8 over by subtracting. So 5x minus 3, absolute value, is equal to 14. So here I'm looking for values of x that would give me a number 14 away from 0. And those possible numbers are 14 or negative 14. So again, two-step equation. We're going to add and divide. So 17 over 5 or negative 11 over 5. Sorry, that's an 11. 11 over 5. Okay. Example 3. Again, before I can set what's inside my absolute value equal to my positive and negative, I need to get it by itself. So we have to divide by this 5 on both sides. So 8x plus 11, absolute value, is equal to 2. So that means that 8x plus 11 could be positive 2, or 8x plus 11 could be negative 2, because both 2 and negative 2 are 2 away from 0 on the number line. So we're going to subtract and divide. So we get negative 9 over 8, or, again, subtracting and dividing, we get negative 13 over 8. Okay? And last on this page, example 4. Again, before I can set my absolute value equal to anything, I need to move that 2 over. So the absolute value of 6x plus 1 is equal to negative 5. Now recall, my absolute value has to equal a positive number because we're talking about distance from the number line. So this particular problem has no solution because my absolute value cannot equal a negative number. It cannot equal a negative number. So this has no solution. Moving on to the back side. Here, I have that absolute value of x minus 6 is equal to 2x. So remember, that means I'm looking for values of x that would give me a number 2x away from 0 on the number line. So we still have to do, whoops, focus. Come on. Sorry about this, guys. I don't know why this camera does not want to work with me today. There we go. So we're looking for the positive and the negative values. So 2x could be the positive of x minus 6, or 2x could be the negative of x minus 6. And using these parentheses here is super important because we have to remember to distribute that negative sign. So if we have the positive of x minus 6, we would just subtract x on both sides, and we get that x is negative 6. If 2x is equal to the negative of x minus 6, we distribute that negative sign, and that will give us minus x plus 6, because a negative times a negative is positive. So then I move my x over, 3x is equal to 6, divide by 3, and x is 2. So we have two possible values for x. We have negative 6, and we have positive 2. So are both of these a possible solution for the equation? Remember, this up here at the top, absolute value of x minus 6 equals 2x, was what we were solving. So we need to plug in both these values to make sure they're a possible solution. Let's start with 2 first. If x is 2, then the absolute value of 2 minus 6 is equal to 2 times 2. So the absolute value of negative 4 equals positive 4. That checks out. If x is negative 6, then I get negative 6 minus 6 absolute value is equal to 2 times negative 6. So negative 12 absolute value is equal to negative 12. Now remember, my absolute value cannot equal a negative number. So x equals negative 6 is not a possible solution because it gives me, when I plug it in, that my absolute value equals a negative number. So this is not a possible solution. Okay. So let's practice this one more time. I have that the absolute value of 5x plus 8 is equal to 3x. So this means that what's inside my my absolute value could be positive 3x, or it could be negative 3x. And I'm going to just draw a line here to separate that previous work. So let's get all of our variables on one side, all of our x values, and we get that x is negative 4. And again, get all of our x's on one side. Sorry, that's a 5x. Don't know why my brain started drawing an 8 there. Minus 5x. So 8 is equal to negative 8x, and we get negative 1. So now again, we need to make sure that both of these values are possible solutions. So if x is negative 4, again, I'm plugging this in to this equation. Absolute value of 5x plus 8 equals 3x. So that would be the absolute value of 5 times negative 4 plus 8 is equal to 3 times negative 4. So negative 20 plus 8 equals negative 12. I cannot have that my absolute value equals a negative number, so this is not a solution. Well, if x is negative 1, let's see what happens. So 5 times negative 1, absolute value plus 8 is equal to 3 times negative 1. And again, I get that my absolute value is equal to a negative number. So this particular problem has no solution. Neither of these x values are possible. Okay. Then the last type of problem is when we have an absolute value is equal to an absolute value. So in this example here, the absolute value of x plus 8 is equal to the absolute value of 2x plus 1. So x plus 8 could be the positive of 2x plus 1 or the negative, because remember, we're talking about distance on a number line. So x plus 8 could be the positive value of 2x plus 1, and if that's the case, then we move all of our x's to one side and all of our variables to one side, all of our numbers, excuse me, and x is equal to 7. Or x plus 8 could equal the negative of 2x plus 1. And remember, we want to use those parentheses because we have to distribute that negative. So x plus 8 would be negative 2x minus 1. And then get all of our x's on one side and all of our constants on the other. And we get that x is negative 3. Now, I want to show you that in this case, I took the positive of 2x plus 1 and the negative 2x plus 1. You also could have taken the positive of x plus 8 and the negative of x plus 8. And I want to show you that you get the same answers if you do that. So I'm going to draw a line here just to differentiate my work. So positive of x plus 8 is equal to 2x plus 1, or the negative of x plus 8, again using those parentheses, is equal to 2x plus 1. Okay? So I'm going to move all my constants over and all of my x's over, and we get that x is equal to 7, or distributing that minus sign, negative 8 minus x is equal to 2x plus 1. I'm going to move my x's over, move my constants over, and I get negative 3. So either way, you get the same answers. The important mistake to avoid is taking the negative of both. Okay? The positive of both, and then the positive one and the negative of the other. The positive of both, the negative one, the positive of the other. Okay? But never the negative of both. Okay, let's practice this one more time with example 6. And again, I'm going to show you both ways. First, I'm going to take the negative of 3x minus 1. And I'm running out of a little room here, so let me actually move this down a row just so I have more room. Okay, so let's do the positive first. I'm going to move my numbers over, and we get that x is positive 3 over 2. Then if x plus 2 equals the negative of 3x minus 1, using those parentheses, distributing the negative, get all my x's on one side, and I get that x is negative 1/4. So that was taking the positive and the negative of 3x minus 1. We also could do the positive and the negative of x plus 2. So let's do that again, just to reiterate that you can do it either way. Making sure we're using those parentheses to distribute the negative. Okay, so again, we get 3 over 2. Oops, paper slipped. Distribute that minus sign. Get all my x's and all my numbers on the same side. And I get the same values for x.